So you can see here that the first hop again has no label. The second hop has an MPLS label. The third MPLS hop, actually you can see where they are taking that 24 label in and actually pulling it off. Their penultimate hop popping it. And then it actually goes through and hits that third router, and then you don't see any more tracing, because 30.2 is actually the other office. So that is basically, from the company's perspective, how it sees it. It sees it as just inner area routes. So you can see how cool this is, that most people don't see any of the infrastructure associated with MPLS on the ISP side. So let's minimize this and let's actually move up, and let me actually do a show run for you, so you can actually see, in case you guys have never done multi-link PPP, we'll go through it real quick, but that's not the direct focus of this video. You'll see we have our serial. All you do is PPP multi-link group 1. That's all you have to do, and make sure you set the encapsulation to PPP. And once you're done with that, you're good to go. One OSPF, instance. Nothing crazy there. Nothing out of hand. Very simple. So that's basically the company configuration. Let's take a look at one of the backbones, the provider edge routers here, where all the hardcore stuff is done, so we can take a look here what we have. Now here I want to show you the IP addresses on this box. You'll see I have 4 serial ports. They are all enabled and on. I have 2 multi-link PPP groups. Of course, one is going to company A site 1 and one is going to company B site 1. The same thing is also on the other side. I have 2 multi-links going to each one. So let's get back to that I just minimized here. So that is basically, and the only loopback I have is the actual loopback for LDP and MPLS. You'll see it has 2 Ethernet connections. One that connects to ISP router 1 and one that connects to ISP router 2. And if I do a show run on those interfaces, you will see that they only have the MPLS IP command. So that's pretty simple. That's basically what you get. Now I wanted to show you that there are 2 multi-link groups. Again, you notice the IPs 150.20.10.254 on one and 192.168.20.1 on the other. Now I want to show you the IP table. Notice how, tell me what you don't see. Tell me what looks wrong with this table. Okay, let's go up. Show IP route, right? We got connected routes and OSPF routes. First you have all the loopbacks, 1, 2, 3, 4, and 5. Right? 4 is a connected, 1, 2, 3, and 5 are not. They're via OSPF. Right? So that looks good. Then you have all the 192.168 addresses for the company backbone. But what don't you see here? And I'll give you a second, but I'll go through it. You don't see any of the multi-link PPP IPs. If I do a show IP int brief, include multi-link, let's do include multi-link. There we go. What do you see here? Those are not in the routing table, are they? At all. Those are not in the routing table at all. So where are these at? How can you have a connected interface that isn't in the routing table? It's a good question. And the main thing is that these are in a separate VRF. So now we're going to get in and talk a little bit about VRFs. So a VRF is a way to have routes in a specific routing table, and it's separate from the main table. It's its own isolated instance. If you're familiar with Junos or any of the Juniper switches, you'll know that they only use VRFs. They don't have anything equivalent to a Cisco route map. If you want to policy policy route something. So if you want to do a PBR, policy-based routing, if you want to change it in Cisco, if I wanted to say take all the packets coming in on this interface, if their destination is site B, then I can change the next hop on those packets to go somewhere else. And I can do that very easy with a route map. Route map 10, permit, enter, match, access list, whatever, and then do this to the packets. Change this, change that. It's very simple with Cisco. But with Juniper, they don't really have that route map concept at all. What you actually do, which is kind of interesting because it's more of a standards-based approach, consistent with VRFs. Cisco has a lot of baggage from when there weren't VRFs. They're an older company, so they have route maps, which I think are easier to use. But one of the interesting things on Junos is that if you want to change the default hop, there is no route map where you can just change the packet. What you have to do is create a whole new routing table, add all the connected routes, import all the routes from the original routing table with the exception of one, and there's a command language to do that. And then with that specific route that you're not importing, you can change the next hop in that routing table to point somewhere else. And then what you do is you say in Junos, you would say on the interface, permit this packet, but set the routing instance to routing instance B or VRFB, or whatever the other virtual routing table is. So it's kind of, I guess, interesting based on your background. But enough of that. Let's get back to the topic at hand. Enough of the Junos. So you see that these two interfaces are not in the routing table. So let's go take a look at our table. Let's do a show run here, and let's take a look at the configuration on this guy, because he's got quite a few things going on. The first thing you're going to see are the two VRFs. Let me scroll up here. They don't exactly fit. IPVRF company B, IPVRS company A, right? You'll see that you can put underscores, so whatever helps you guys make things more legible. IPVRF company B creates the first VRF, right? The next thing it does is a route distinguisher. I want to tag all the routes that come out of this table and say router 4, which now that we know that, we can look back and say, look, there's router 4 right here. I want to say router 4 initiated these routes. I basically am responsible for them. So that's what that does. And then the colon 2 is the unique ID number for company B. It only exists for company B. There cannot be another 2. The next two commands here are really entered as one. You can do route target both, and it puts import and export. And I'm saying, so what this command says is export routes out of this table to BGP instance 65,000 with the extended community string showing that this is company 2. You notice that's the same as the route distinguisher. The other one says only put routes into this VRF if they come from the routing instance for BGP of 65,000, that AS number, and they match company 2. So that's how that works. Now these could be different routing instances. If you want to get really complicated, they could be even different numbers. Let's say I wanted to match routes from VRF A and add them to a VRF C, and then that would be like a combined VRF. And there's reasons why you'd want to pull routes out of different VRFs for different things. So you can set up you can see how complicated, or not complicated, but flexible and scalable this is. So that's basically it. Now I want to go back before moving any further in the config, and I want to show you. I show IP route again. Connect interfaces aren't in there. Now if you do show IP route VRF, look at that. This is a new command. Let's type company B. What do we have here? We have, look at all these routes learned from OSPF. 10.0.0.3.1, 2.1, 10.0.1.1, 10.00. These are all OSPF routes. Now what do we know? Let's go back to our map. We know, let's use our other drawing. We know here that the provider router has an OSPF connection with company B. So if routes are learned via OSPF, they must be from the locally connected router. Correct? Now, the other thing we have here is, look, we have some BGP routes and even a connected route. Look at that. The connected route is the actual physical connection, and the BGP routes are coming from the other router, the other site. So if you look here, it's easy to see that these BGP routes, get my highlighter here, that one, these two are all coming from the other site. There's some down here as well. And notice that they only show the routes from the companies, from company B. They only show company B routes. They show them from both sites, but they only show company B routes. Notice they don't show company A routes, and notice they don't show any routes belonging to the ISP. That's very important to understand.